Hey everybody, so we're going to be talking about polygon angle sum theorems today. There are two types, and each of them have a corollary, meaning like, hey, by the way, you can also use this. If you know the theorems, then you'll be fine. You can figure it out with just the theorems, and you do not have to memorize the corollaries. All right, so your notes should look like this. We've got our interior angles theorem and our exterior angles theorem. All right, so the first one is our polygon angle sum theorem, is what it's colloquially known as. We tend to not say interior when we're talking about this because the angle sum is talking about the inside typically. Now, this angle sum of the measures of the interior angles of an n-gon. So no matter what it is, if it's a hexagon, meaning it's got 6 sides, a pentagon, meaning it's got 5, a trigon, which means it's got 3, okay, it's going to be 180 times n minus 2. This right here is a formula that you really need to know. If you don't know this next corollary, you can still figure out your life. All right, so the corollary of this says that, by the way, you can also figure out the measure of each interior angle of an n-gon, and you want to make sure to put down of a regular n-gon is 180 times n minus 2 divided by n. So however many sides there are, you're going to divide it by that. All right, quick tip. In order to name your polygons, all right, it's just n sides, it's an n-gon. If you want to pause it, take a picture of this, keep it for your reference, however you want to do this, you can. So here's penta, meaning 5, hexa right here being 6, hepta 7, octa 8, nona, deca. Most people don't use this. There are just all sorts of different ones. There's dodecagon, there's duodecagon, which means it's 20-gon. But after 12, typically we just say a 13-gon or a 14-gon. All right, so find the sum of the measures of the interior angles of the indicated convex, this is important, polygon. And that's what we're mostly going to be working with. All right, so a nonagon means that it's got 9 sides, the 9-gon, and your n is going to equal 9. We're going to use our theorem and drop the 9 in. So 180 times n 9 minus 2, which is our n. We do 180 times 7, which gives you 1,260 degrees. That's how easy that is. You can figure out the angle sum for this just like that. So the same thing's going to happen with the dodecagon. That's a 12-gon, meaning it's got 12 sides and your n is 12. So all you're going to do, write that formula in. And this is the one I always remember. You do not have to worry about the corollary as much. All right. So drop that 12 in. You're going to multiply it by 10. You don't need a calculator for this one because you get 1,800. All right, for this next one, your n is going to equal 23 because it's just a 23-gon. So you can just drop that in. That gets you 21. Multiply it by 180, and you get 3780. Now, notice I'm using the same formula over and over again. This is our theorem. It's part of our definition because the converse also works. What we're going to do is we're also going to use the corollary. And I'm going to use it on the dodecagon. You don't have to write this down, but you can if you would like to. You can do it on the back of your notes. The corollary states that we can figure out the measure of each of these interior angles by using this formula. So getting our total angle sum and then dividing it by the total sides. Well, that makes sense. You didn't even have to have that formula to figure that out. But if you wanted to, let's try with the dodecagon. Got 180 times n minus 2 all over n. Drop my n in, which was 12. And I got 180 times 10, which I already knew was 1,800. So 1,800 divided by 12 and you get 150. So that's how you would figure out that each of those, and I'm not going to attempt, well, I am, because dodecagons are really hard to draw. Yeah, we're going to pretend that's a dodecagon. But each of those is 150 degrees. All right, so now you can also work backwards. So the sum of the measures of the interior angles is given. We have to classify what type of polygon it is. So I've got 1440 as my total. So I'm going to set my equation equal to that. And then I'm just going to solve for n. You can distribute the 180 first if you'd like, but I'm going to get rid of the 180 by dividing it, so that all that's left for me is n minus 2 equals 8, because that's what 1440 divided by 180 is. And then you add the 2, and you get n equals 10. It was that easy. All right, so this would be a tengon, but because we know the name for it, we would say it's a decagon. And this would be our answer. All right, for the next one, same thing, set it up. Divided by 180. Work smarter, not harder. If you do end up distributing, by the way, you get 180n minus 360 equals 2700. So you add 360 over, and you get 3060, I believe. And then you divide both by 180, and you should get 17. Now, it doesn't matter which way you work it, because here's the deal. You're still going to get the same answer. Do what works best for you. I think this one's working smarter, and this one's working harder, but you might think it's the reverse. All right, let's do this next one, and I'm going to do it my way, because it makes it easier for me. All right, we've got n minus 2 equals 49, which means we've got a 51 gon. Yep, that's right. That's a thing. All right, and that's how easy it is to work with the interior angles. The exterior angles, they're even easier. So the exterior angles theorem is that the sum of the measures of the exterior angles of a convex, this is important, polygon, is one angle at each vertex, okay, is going to add up. So, right here, each of these add up to be 360. That's how easy that is. They're all supplements to the interior angles, so they're going to add up to be 360, and it's crazy how that works out for every single shape. Now, the corollary to the polygon exterior angles theorem is that the measure of each exterior angle of a regular n-gon, so you could figure out what each of these is if it's a regular polygon. And I want you to remember that from your vocabulary. It's both equilateral and equiangular. It's just going to be that 360 divided by how many sides there are. That's how easy that is. All right, so again, you can figure this out. All right, you don't need the corollary. You just need to remember that exterior angles is 360 degrees. We're going to do these two examples together. You are going to do C and D on your own. Take a picture and submit it. All right, so remember what we said. This plus this plus this plus this is all going to add up to be 360 degrees. Now we're looking for x, so we're going to simplify and combine like terms. Move over our 168 by subtracting. Divide by 3, and you get x is equal to 64. Told you guys exterior angles was so much easier. All right, so now same thing. We're going to add up all of these exterior angles. Simplify it, okay, because we've combined our like terms. Subtract the 120 and divide both sides by 16, and you get x is equal to 15. It's that easy. And you guys can do this. All right. Like I said, you guys can do this. So you are responsible for C and D, and you are to upload this to get credit for today's notes. Thanks for watching.